Good afternoon, and thank you for joining us for the 14th webinar in the Offshore Wind Series Learning from the Experts. I'm Peter Lyon, Senior Advisor with NYSERDA's Offshore Wind team, and it's my pleasure to be joined by today's experts, Jamie MacDonald and Jeff Tingley with Xodus, who will be giving a joint presentation on offshore wind supply chains. Before I introduce our speakers, a few reminders for participants and some background on the webinar series. Next slide, please. First, if you're experiencing any technical issues, please contact Sal Graven at the email address on the bottom of this slide. This webinar is being recorded, and the recordings and presentation slides for all webinars in the Learning from the Expert series will be available on NYSERDA's website at the address on this slide. All participants have been muted. We'll have time for Q&A following the presentation, so please use the Q&A function to submit your questions for the speakers. Next slide, please. New York State is working to advance the responsible and cost-effective development of at least 9,000 megawatts of offshore wind by 2035. Offshore wind is a critical component in achieving the state's goals of 70% renewable sources of electricity by 2030 and 100% zero emissions electricity by 2040. While offshore wind has been providing clean energy to other parts of the world for several decades, this industry is brand new to New Yorkers. To provide interested stakeholders and members of the public with accessible, impartial information and opportunities for engagement on specific topics of interest, NYSERDA is hosting this educational webinar series called Learning from the Experts to connect the public with independent experts in key topic areas of offshore wind. We endeavor to select Learning from the Experts series based on their expertise, not necessarily for alignment of opinions with NYSERDA or the state of New York. If you'd like to suggest a topic or speaker for a future webinar, you can email us at offshorewind@nyserda.ny.gov. Please note that the views and opinions expressed in this presentation are those of the presenters. Next slide, please. It's now my pleasure to introduce Jamie MacDonald and Jeff Tingley. Jamie is the Director of Renewable Operations at Xodus and is responsible for helping shape and grow the U.S. business in terms of technical strength, commercial performance, and brand awareness. Jamie has a strong track record of managing large projects across the offshore wind industry. With a marine and offshore construction background, including supervising contractors during operations, he is well versed in how to deliver marine construction projects from pre-feasibility through execution and into operations. Jeff Tingley is the Head of Strategy and Market Development at Xodus. He has extensive experience in supply chain development for offshore wind and other renewable energy sources. He has completed and managed an extensive list of supply chain development analysis for various regions in the U.S., providing supply chain strengths and gap analysis and ascertaining the area's strengths by evaluating adjacent industries. He also has helped large OEM and Tier 1 companies establish operations in the U.S. in support of the country's growing offshore wind sector. Without further ado, I'd like to kick it over to today's presenters. Thanks.
Thank you, Peter, and thank you very much for that very kind words and kind introduction. I want to say, first of all, thank you to NYSERDA for having us on this webinar. It's a great opportunity for us to tell the attendees about offshore wind and how the offshore wind supply chain is built and how we speak about it in the industry. So, and thank you all for attending. There are time for questions at the end, so please feel free to send your questions in through the Q&A tool, or conversely, if there is something you want to bring up with us separately, our contact details are provided at the end, and you can contact us directly to arrange a further discussion. Next slide, please. So Xodus Group is an energy consultancy. We are globally based, headquartered out of the UK, but with 3 offices in the United States, that being Boston, Massachusetts, Providence, Rhode Island, and Houston, Texas, with a presence of over 25 people in the US locally and 350 worldwide. We believe we have a unique range of skills and services that encompass commercial, technical, and environmental space in the offshore environment that leave us uniquely positioned to opine and assess supply chains for nascent industries such as offshore wind in the US. Our understanding of how offshore wind farms are built and permitted and operated gives us that technical know-how and background to provide a robust assessment and ensure that we are providing action plans and recommendations that are fit for purpose for the regions in which we are doing the assessments. We've been lucky enough to date to provide offshore wind supply chain assessments for multiple states and local regions, including Massachusetts, Maine, Hampton Roads, and more recently, and Jeff will speak about this, the Capital Region in New York. Next slide, please. I think Peter's spoken about and given us an introduction, so I'll skip on to the next one. So the agenda for the day for this presentation is we're going to speak about the taxonomy of an offshore wind farm. So how do we slice and dice and break down and categorize all the components of an offshore wind farm? And then generally, how do tier ones or offshore wind developers contract their major packages into the supply chain, and what are the differences in doing so? I'll hand over to Jeff after this, where he will go and speak around how we've created a methodology for assessing the offshore wind supply chain. We believe a concise, robust, and consistent methodology that can be repeated across regions and allow us to provide meaningful comparison across the US in terms of offshore wind supply chain capability. Then Jeff will move into some trends we are seeing form in the US, and then we'll have time for questions at the end. Next slide, please. So the first section we'll talk about is the taxonomy of an offshore wind farm. Next slide. So taxonomy of an offshore wind farm is just a way of communicating the different procurement or construction or operation activities associated with the life cycle of an offshore wind farm. These tier one levels, as we call them, being project development, turbine supply, balance of plant, installation and commissioning, operations maintenance, are ways in which offshore wind developers will typically communicate their needs and their contracting requirements to the market. So as we speak about it, we try and mirror that and be receptive and reflective of their needs and requirements. We've also included as a tier one component sector support. Now, sector support isn't necessarily a supply chain element for an offshore wind farm, but there are key activities under sector support, including training, research, development, and professional services that are required, especially in a nascent industry like US offshore wind, in order to progress projects and provide cost reduction and upskilling of the workforce that is required in order to meet the goals set out by the government. So an offshore wind farm can typically consist of over 8,000 components. A lot of those components are found in the electrical equipment in substations and also in the turbine nacelles themselves, which we will come on to. There's multiple tiers of supply. I've listed the tier ones, but we'll also talk about tier twos and tier threes, and sometimes tier fours. And these are just subsets of the tier ones we spoke about just a minute ago there. So for turbine supply, we would call that tier one original equipment manufacturer, with the subset tier twos being nacelles, rotors, and blades. for example. Procurement for equipment, fabrication, and services is launched years ahead of a developer making financial investment decision. So while it appears projects are maybe 10 years away from being operational in the water, procurement starts well before that, as does project development activities. With there being over 8,000 components, it's unrealistic to think that everyone will be engaging directly with an Ørsted or an Equinor or an Avangrid. Most of the time, they will just contract directly with 2 to 8 key tier 1 package suppliers, and it will be the responsibility of those suppliers to engage with the supply chain further down to procure items such as secondary steel or civil works or survey works, for example. Next slide, please. So the first supply chain element we're going to speak about is project development. So project development occurs when an offshore wind developer is thinking about acquiring a piece of seabed to build an offshore wind farm. Like we're seeing just now in the New York Bight with the upcoming lease auction for 8 sites, developers are starting to think about their early stage project development plans. They're starting to think about permitting strategies. They're starting to think about levelized cost of energy modeling. They're starting to think about field layouts and strategies for installation. Once they've acquired that site control and look towards delivering energy to the market, they're going to be looking at permitting services. They're going to be looking at met ocean and resource assessments, including floating LiDAR and wind resource surveys. They're going to be contracting vessels to do geological and hydrological surveys, and engaging with design and engineering firms to provide foundation design, cable routing, landfall assessments, O&M strategies, etc. They are procuring these types of services up to 10 years in advance of commissioning. And often it is sourced competitively and, where possible, with a local bias, particularly on the permitting services and environmental aspect, where an understanding of local state regulation policy and local environmental sensitivities is very important. Next slide, please. Now, by volume, in terms of CapEx spend, arguably the wind turbine generator itself is the most expensive piece of equipment you will be, or the project developer will be installing on an offshore wind farm. We've seen recently GE, Siemens, Vestas have all announced next generation turbines in the region of 15 megawatts, and potentially with the next generation beyond that, looking at 18 megawatts, 20 megawatt turbines. When you put that on a scale, you can be looking at from seabed to the tip of a blade, you could be looking at the height of the Chrysler building, just to provide a sense of scale of the infrastructure that's going to be installed in a marine environment. So these designs are highly unique and proprietary to the OEM. There is equipment in there such as pitch drives and bearings, structural fasteners, cooling systems that are all bespoke to the equipment and the setup within that wind turbine. And as such, they are not off-the-shelf components. So you really need to, if you feel like you have components that could support the wind turbine generator, you really need to be involved at an early stage with the OEMs, building that relationship and understanding their requirements for their next generation turbine and how your solution can, or equipment can feed into there. They are generally purchasing and starting building these turbines for a project 2 to 3 years before project construction. Next slide, please. Balance of plant. So this is essentially everything aside from the wind turbine generator used to support the offtake of electricity from the turbine to the landfall and into the grid. So these can typically be your foundations of which the wind turbine sits, secondary steel to support those foundations, such as J-tubes, boat landings, ladders, cable trays, etc. It can be the cables themselves. It can be the onshore infrastructure and substation, the offshore facilities, scour protection to support the ongoing maintenance of equipment on the seabed. And again, it is designed and sourced typically 2 to 3 years before project construction. Subcontracting is normally, procurement is normally subcontracted on a competitive basis by the tier 1 OEM. And by that, I mean there are foundation suppliers such as Blatt and SIF and EEW who will subcontract equipment such as the boat landings and the cable trays and the J-tubes. For the substation, you will often see the main electrical supplier subcontract a local civils company and local construction companies to support the onshore construction. Next slide, please. So once we've procured, designed, and we know what our configuration is for the offshore wind farm, we're starting to look at how we're going to install these. Now, for a fixed offshore wind farm, we're looking at very specialized heavy lift vessels to install foundations and jack-up installation vessels to install wind turbines. These vessels command very high day rates. They are in short and limited supply, particularly as we start moving into these larger turbines, and require a significant amount of logistics and marine coordination in order to successfully execute the project. The SSC Beatrice Wind Farm in Scotland had over 30 different vessels utilised during the execution of that project over the course of 2 summer windows. So not a small undertaking, lots of port infrastructure to support it, marine infrastructure, scheduling and weather forecasting in order to line up powering of the turbines, installation of cables, and making sure that it all comes together so that they meet their first power date. Next slide, please. And finally, the last segment I'll speak about is operations and maintenance. The longest duration of an offshore wind life cycle typically could see anything around 30 years. And that would cover everything from offshore inspection to subsea inspection, turbine reactive, preventative maintenance, and can be sourced for multiple people. So the turbine OEM who have a warranty period may be looking to subcontract specialist services to support the maintenance of a turbine. The developer might have issues with seabed mobility and be looking to do seabed surveys in order to understand if they need to replace a scour protection to support the foundations and the cables. So multiple contracts over the duration of a life cycle. They're often sourced competitively, again with a local bias where possible. And we see a mix of frameworks and ad hoc supply. So by that we mean often people can be awarded 3 to 5 year framework agreements to cover offshore cable surveys, for example. But also there's the ad hoc supply issue that where they need to be reactive and get maintenance or technicians out in the field to rectify an issue, and they will call on the local supply chain to support them with that. Next slide, please. So now I'm going to speak a little bit about contracting strategies. Doesn't sound like the most exciting topic, but in offshore wind, they can be fairly ambiguous and complex at the best of times, challenging to navigate. And this can be compounded when you're part of a nascent supply chain environment like the US offshore wind industry. And this can generate a lack of awareness on how projects are contracted, and often cited as a barrier for local companies getting involved in offshore wind. So you would think standardized, simpler processes would be key to solving some of these issues, and they are, and offshore wind companies are striving to standardize and make procurement simpler where possible. But ultimately, it comes down to the type of companies and other multiple variables that are influencing it. So this can be the size and complexity of the project to be executed, the internal strength of the offshore wind developer, their experience and capabilities of various contracting strategies to date, the maturity of the supply chain, and also things like the influence of project financing and its availability. So I'll go on to my next slides, talk about three strategies. The first one being a multi-contracting strategy. I would say historically in the US, when we're speaking about solar or onshore wind, these types of infrastructure projects often take the form of a turnkey one-stop contract, and that is well known to financing firms. You're not operating in an offshore marine environment. You don't have increased risk of cost and schedule overrun from managing multiple interfaces. So this is why I would say these types of contracting models are proving challenging when it comes to discussions of project financing in US offshore wind. So a multi-contracting strategy is, as seen here, the owner, operator, developer will typically award separate contracts for these key elements. Everything from substation supply, inter-array cables, supply and install, foundation, supply and install, export cables, supply and install, and then turbine supply and install as well. It offers the greatest control over project development and provides the best opportunities for cost reduction, but it requires an owner-operator to have a very strong in-house expertise when it comes to engineering and project management, and they need to be a lot more involved when it comes to managing interface risk and coordination between the contractors. Next slide, please. An EPCI strategy, so engineering, procurement, construction, and installation, generally have fewer 2 to 4 contracts, larger contracts covering perhaps 3 main areas. So you might have turbines, the balance of plant, and the transmission and distribution. We have seen in Europe this go to just 2, where we've had, for the Gemini wind park, you've had Siemens provide the turbines and install them, and we've had Van Oord do everything else. So Van Oord would subcontract a substation supplier, an electrical supplier, a cable supplier, etc., and they would take on that risk. Generally, it means those contractors, your Siemens, Van Oords in that case, will price in that additional risk and contingency for taking on that interface and project risk. For developers with less experience in offshore wind, this is perhaps quite an attractive solution, as it takes away that unknown part of having to provide that interface and guidance between all contractors. Next slide. But I guess what we see most of all in the industry is this hybrid strategy, where you're seeing multi-contracting and EPCI being looped together. So in some cases, you might see export cables supply and install grouped together. You might see interarray cables and foundations supply and install grouped together. Turbine supply and install kind of grouped together. And I guess the reason for that is people want the best of both worlds. They want to reduce interface cost and schedule risk. But with that comes reduced project oversight. Developers in a new sector and a new industry don't want to lose that oversight, but also don't have the capabilities or the depth of capabilities to execute this without going down the EPCI route. And I think a good example of this is Vineyard Wind, for example. I believe it was something in the region of 6 to 8 projects, packages that they went out with. They went out with the turbines, they went out with the install of the foundations, transport and install the foundations. The design was outsourced somewhere else. The supply was outsourced somewhere else for those foundations. So multitude of different options when it comes to contracting strategies. So hopefully that's given you an overview of the supply chain elements and the different contracting models. I'm going to hand over to my colleague, Jeff Tingley now. Jeff. Jeff, are you there?
Oh, yes. Can you hear me?
Yes. Yeah.
Okay. I'm sorry. Well, thank you everyone for attending this afternoon. And Jamie, thanks for your great work as always. You know, the interesting thing about the offshore wind supply chain and how to assess it is if you look at the offshore wind industry in the US right now, a recent study just came out that said that there's going to be about $100 billion in CapEx and 83,000 workers needed to support the offshore wind supply chain. If we look up and down the East Coast, if we include projects that are currently in construction, projects that have been permitted, lease areas that are about to be put out for bid, there are 30 separate projects. So we have a real challenge ahead to get all this work done. And this work is going to depend on a very robust US supply chain. And so what I'd like to talk to you about this afternoon are just some supply chain methodologies and capabilities, as well as what some of the trends in supply chains are. Next slide, please. We find that, you know, in assessing the offshore wind supply chain, there's really 7 major factors you have to go to. First of all, is there experience in offshore wind? So those are really the number of companies in an area, in a state, in a region that say they have the capabilities to support the offshore wind segment. They've been doing it maybe in onshore wind, or they've been doing it in Europe. The other one are adjacent industries, and those are the industries that have components, products, and services which are directly translatable into the offshore wind space, but are being used in a different area. A simple example is someone who is welding and developing secondary steel to put on cell towers could be doing that same kind of work for an offshore wind tower. And the third is market volume. Is the volume of products required to support the offshore wind farms and multiple projects going to be a major piece of that company's business? Also, the advantage for a local supply chain. You know, it is the hope of all the large developers, all the large tier 1s and OEMs to source as much locally as possible. Just sort of a point of context here is that in the year 2025 or 2027, in that sort of 2-year time frame, there are going to be as many as 300 turbines per year commissioned. That really requires a lot of things to be done locally. So there's a real advantage in using a local workforce, local products, and local industry to drive the industry forward. There's also the opportunity within the supply chain is for them to export products through that OEM or tier one in other operations they may have throughout the world. The US is not the only growing offshore wind market. It still continues to move ahead very quickly in Europe, also in Asia and Latin America. So if you look at the diagram, the spider chart on the right, we really look at those taxonomy categories that Jamie talked about in those terms. And what this does is it really tends to identify where there are gaps in the supply chain, where the supply chain is efficient, where the adjacency lives, and also as a result of that, what is the investment and what is needed in order to grow the supply chain. So this is a methodology which we've applied in many instances and really gives a very real world, real-time view of supply chain strengths, supply chain gaps, and supply chain potential. Next slide, please. We've started this process for the CEG in Albany, really focused around the Port of Albany and the Port of Coymans. It's interesting to look at those two areas being up the Hudson. One already has a very large supplier in Marmon that is building foundations, etc. And so we are looking at what is in that area and what is needed. Whoops. Next slide. Yeah, oh, thank you very much. So we are looking at and evaluating what the existing supply chain is, and also what are the adjacent supply chain opportunities. We do this through interviewing developers, tier ones, and the stakeholders within a region to get a real sense of what they're looking for in a supply chain and really what they have. And then trying to marry those with a set of recommendations on how the capital region can capitalize on what it has, how it can take its assets to use those as a way to grow economic development and grow the supply chain in the region, as well as to look at the best forms of investment for workforce development, capital equipment, and how to really build robust support for the offshore wind industry. And that study is expected to be completed in early 2022. We've just kicked it off now. So that really is a model for how the state can look at its supply chain and how it can grow its supply chain to support its burgeoning industry. Next slide, please. There are trends that are happening in the supply chain now. As we now have, as we now have projects that are quickly moving into the construction phase, we have records of a decision which we hope will be coming out shortly. We have a number of permanent areas coming up. We have COPs that are in BOEM. We believe that there is a confidence now in the U.S. wind industry, and that confidence is trending towards investment. That confidence is trending towards developers, OEMs and tier ones looking at multiple projects, not just a single state project, and that is creating great opportunities for the supply chain. So next slide, please. Obviously, it doesn't take a rocket science to figure out that the bigger the piece, like the nacelle, the turbine, the foundation, etc., the closer it has to be to the water. So the clustering is really taking place around ports. And this clustering is happening because of projects, but also happening because of the locations of the existing supply chain in certain areas that is driving other industries. And so we see this clustering continuing, and you see on the left-hand side the areas where that's taking place, going from north to south, if you will. And what's important about these clusters is that while they will support local state projects, they're really designing themselves to support multiple projects across multiple states over multi-year periods. And this is what really is needed in the industry and a trend as investments take place and as supply chains develop. So one can expect to see these clusters do nothing but grow. And we expect this to be a trend in the next 10 years ahead. Next slide, please. As Jamie mentioned, one of the challenges is the timing. And the timing is from the time one begins to plan for a lease area till you actually start or finish construction can be 10 years. And the supply chain to support offshore wind, the components that are needed, the components that the OEMs and tier ones or even tier twos to tier threes to tier twos require have various phases of acceptance and a compliance into the tier one or OEM supply chain. There are different levels of health and safety. There are different levels of manufacturing. There's different levels of certification. And so it's really important as we grow the supply chain and as we look at some of these longer lead time items, there is a need for OEMs and developers to work closely with potential supply chain partners to ensure there's an understanding of what their requirements are as they move towards product acceptance, and also the time frame. If a supply chain company has a quote unquote critical component, that compliance period can be as long as 2 years. So it's very important that those sorts of things are known upfront and that there's a close relationship between the supply chain and the procurer of the product or services in order that everyone understands the expectation, the commitment of time, money, and resources moving forward in order to be pulled into the supply chain. This is especially true in the adjacent industries, and making sure that they can meet the requirements, as I said, the technical requirements, health and safety requirements, also the volume and requirements, and be able to do that in a time frame that's compatible with project development. That's why it's really important for the supply chain to get involved early and for conversations to begin early. That's also why, as Jamie mentioned in his part of the presentation, we classify the supply chain within that wind taxonomy. So when excuse me, so an OEM in tier one is talking about an electrician, they're not talking about the person that puts a new circuit in your house. They're talking with someone that's able to handle high voltage, as an example. So it's really the conversations that are taking place between supply chain and supplier at a level that both understand the expectations. And I can tell you that the OEMs in the tier ones are very, very open and to ensure that the information they supply and they can help walk companies through that process. So it's a critical communications effort, and that effort is to the advantage of both the supply chain, the developers, the OEMs, and the tier ones. And so as we look at this long time frame, there is work that can be done, but the timing depends on the critical nature of the product and the volume of product required. Also, if you look at this development cycle, there's certain services and certain requirements that are involved 2 years before the product starts construction, and some that don't start until after the product is actually spinning in the water. So when they talk to companies is really directly related to the time frame of the development of the wind farm. Next slide, please. So the US trends are the early projects, which we're sort of in right now, most of that work is going to come from overseas, and it's going to be shipped over here. There isn't it's not like they can plug into an existing supply chain. We're doing a great job of growing our supply chain, of getting our supply chain set, of going through the process to really establish a U.S. supply chain. But the initial project, much of the work is going to come from overseas. However, those vendors coming from overseas do want to and are anxious to form the relationships in order to grow a U.S. supply chain. You know, these projects have strict timelines, strict penalties for cost overruns, etc. Therefore, they want to know that they can deal with someone down the street or in the next county in order to get work done. So it's to their advantage and to their benefit to build a supply chain. And that's what's really happening right now. As we get multiple projects, as I said earlier, coming online with line of sight visibility of multiple projects, as I said, this trend towards creation of a local supply chain is going to accelerate and gain momentum. So the time to get involved is now, and I would encourage, and I would encourage that at this point. We feel that, after 2025, 2026, there is going to be a robust supply chain. And because we do have the know-how, we do have a lot of the adjacent industries, there just needs to be a transition period. Next slide, please. One thing that's also driving the supply chain is this pressure on price. If you look at the PPAs, so the agreements the local utilities have on what they're going to buy the power for, there's a downward trend on price. And that downward trend on price really is going to manifest itself in a couple of ways. First of all, there has to be, as Jamie talked about in his contracting thing, there has to be efficiencies over time. There has to be efficiencies across the industry, and there have to be efficiencies across projects. That is done by a local supply chain. One can be more assured of time schedules, therefore lower risk. One can be more assured of easy relationships between OEMs and tier ones if that company is local. So the price pressure on offshore wind farms, and as we get more of them out there, the price will naturally come down. Part of that is going to be a local supply chain, and having that support around the clustering, which I talked about earlier. We don't see this changing. It's not going to drop, obviously, as fast as it has in the past couple of years, but price pressure becomes very, very strong. Next slide, please. So other U.S. trends, things that are really important, I think. You as the supply chain, I know many of you want to talk with developers and OEMs. I can tell you that developers and OEMs want to talk with you. So the great communications and matchmaking things that NYSERDA does are really important to take advantage, to build those one-on-one relationships with your potential customers and your potential partners. They're looking for this. They want this to happen. And so you have a willing audience. There is also a great opportunity for a diversity, equity, and inclusion. The supply chain includes hundreds of components, hundreds of services, and that allows the development into underserved communities and other areas where great economic development and great gains can be done by partnerships between the supply chain, developers, OEMs, and tier ones, etc. It also is a great opportunity for labor, to get labor involved in training, to get labor to supply the workforce, and there's labor agreements between the major suppliers and the unions in order that we can meet the workforce needs, not only the product needs, as this industry grows. There's also, as we could see by the current president's administration in his Build Back Better program and the EDA grants, there's a strong focus on grid upgrades. And work has to be done in order to support those upgrades. That's going to be access roads, bridges, etc. So the opportunity and some of these upgrades around ports, etc., are going to be directly related to offshore wind. There's one final point here about upgrades. The grid needs upgrading. So there's a lot of work that has to happen on shore as well. So when one looks at the offshore wind supply chain, one should not look at just what is out at sea, but also all the work that has to take place once that power hits the shore. That is an extensive opportunity for supply chain companies as well. And I know that the major power companies and power distribution organizations are actively developing their supply chain because they know that much work has to be done. Next slide, please. So I hope that was very fast view of sort of how we look at the supply chain and some trends in the supply chain. And I wanted to leave at least 10 minutes for questions, so I've done that. And Jamie and I would be glad to answer any questions you have, or if there's any in the chat that we could respond to. So thank you all.
Thank you both, Jeff and Jamie, for that great overview of the offshore wind supply chain, contracting terms, and trends that we're seeing in the U.S. market as it is unfolding. We've had a couple of questions come in, and I'll go through them. So the first question is, can you give us a sense for the cadence of spending on these projects? What percentage is spent before build out starts, and what percentage is spent after?
Sure. I can take a run at this. So typically, when we speak about offshore wind, we talk about it in terms of the levelized cost of energy. So that cost is comprised of capital expenditure, including development expenditure, operational expenditure or OpEx, and decommissioning expenditure. And the way we kind of break that down is a way to benchmark projects comparatively against each other, regardless of capacity, turbine size, etc. So we have a good way to compare the cost of projects. So for example, if we're saying, for ease of calculation, a project is $100 per megawatt hour, we would expect to see 30 to 35% of that taken up between operations, maintenance and service, and then the decommissioning portion. Before build out, we're probably looking at the other, 65 to 70%, and that can be split up in multiple ways. You're probably looking at between 3 and 5% to be spent on the development and project management side of things. You're probably looking at another 30% of your project cost, CapEx costs, to be spent on your turbines. So that's probably, and then probably a third of that itself is probably in the nacelle itself. You're probably looking at 15 to 20% for balance of plant procurement, and then you're probably in the region of 15 to 20% again to when it comes down to installation. So I hope that helps answer that question.
Yeah, I think that's a great breakdown. I think if I remember from some of your earlier points on that operations and maintenance, that's over a 25-year time period, and includes both services as well as manufactured components and consumables. Can you just touch on maybe a few other scopes there, possibly related to those?
Yeah, so the turbine OEM will typically come with a warranty period, during which time they will be responsible for going out, replacing wear and tear in gauges and brakes and gearboxes, bearings, etc., bolts, all the internals, including cable trays, lighting, low voltage wiring, etc. So that will cover that side of the turbine. Beyond that warranty period, typically people will either outsource that to a third-party specialist company to continue doing that, or they will renegotiate with the OEM for further support as into the asset life. As you go down through the balance of plant, you're going to have foundations which are exposed to seawater, a corrosive environment when you put steel in it. So we will be ensuring things like paint and cathodic protection anodes have sufficient coverage to maintain the cathodic protection of those structures. We will be looking at surveying the cables to ensure they maintain a depth of burial that is in compliance with the regulations, and monitoring seabed mobility to ensure the foundations have not become exposed in a way that they're no longer able to provide sufficient load protection from the turbine and in the environment. So onshore, obviously it's a lot easier. That can be done. Logistics are less stringent, and it's easier to be changing out components on an as required basis. The logistics required for offshore maintenance are quite high, and often offshore wind developers will use something called an SOV, so a special operations vessel, which has a gangway walkway between the vessel and the wind turbine, and that will be heave compensated to allow for safe transfer of personnel. And they will plan whole summer seasons around the utilization of this vessel to ensure that their wind farm is appropriately maintained.
Great, thanks for that. Another question that just came in. Given the long lead time associated with these projects in the well-established supply chain, how often do delays occur, and what are the most vulnerable points in the process?
I could sort of start that. I think the most vulnerable points and when the delays occur are during the permitting process. It's during the time when the environmental surveys are done, submitted for comment. It's the COPs going into BOEM and the comments that come out of those. So it's really, I don't know, Jamie, what you think. I think much of the delays are really in the pre-construction period.
Yeah, and that's fundamentally down to, we've only got 7 turbines in the water at the moment, so
Right.
there's no precedent yet for almost like a train or a serial permitting of these projects. So until we get into a bit of a routine with that, what that permitting process throws at these projects in terms of if they need to do more stakeholder engagement or avoid perhaps new environmentally sensitive areas is going to be a concern. I think we've seen in the UK projects that have perhaps been delayed have been down to cumulative environmental impacts in the UK, especially when you're looking at birds and bats, and other environmental delays that have been caused there have also been down to seascape, landscape, and visual elements of projects. We've also seen poorly acquired geotechnical and geophysical data that has resulted in significant resurveying work being required to ensure that they have robust foundation designs to support the turbines. So a variety of things can cause a delay in these projects. I wouldn't say there was one just now that was a standout contributor.
Great. Thanks for that overview. So kind of on a related note to the early stages of project development, we have a question that's come in that talks about, at the simplest level, what are those earliest procurement tasks of the offshore wind farm? So maybe you can just give some of the examples associated with permitting or some of the environmental work that's done, so we can get to maybe one more question after this before we've got to close.
Sure. Yeah. So I guess in the development in the earliest stages of an offshore wind farm, developers are going to be engaging with environmental survey companies to understand biological, physical, and social impacts of the offshore wind farm. They will be understanding impacts to marine mammals, benthic habitats, the coexistence between the wind farm and other sea users and commercial fisheries. They will be looking at doing early stage feasibility and engineering in order to define what we call the design envelope. So once they have defined that design envelope, they can start doing their environmental assessments and understanding if their project as they propose it, based on the environmental surveys and assessments they have done, will pass muster with BOEM. So that's really the earliest stages where people are looking at. I would say, when we were studying Massachusetts supply chain, we spoke to foundation suppliers who say they engage with the contracting process 3 to 5 years in advance, and they need to understand what their secondary supply chain looks like there as well. So, when a project's announced, it's worth thinking about who your supplier is and how early you need to be engaging with them. Because like Jeff says, it could be 2 or 3 years in advance, it could be 2-3 months in advance. And so depending on the supply chain segment you're operating in, that's really important to figure out where you sit.
Sounds like we're talking about a marathon in some cases versus a sprint.
Yeah.
Really, really quickly, Jeff, earlier you had touched on some adjacent industries that you guys evaluate when doing your supply chain analysis. Could you just mention, 2 or 3 of those adjacent industries so folks in New York can, get an understanding of where they might potentially fit?
Sure, Peter. I'd be glad to. I mean, I did mention one. It's someone who has secondary steel. They may be building and developing ladders that go on buildings, on fire escapes. They may be developing ladders and welding them on cell towers. Those types of services can be used by the offshore wind industry in the foundation and manufacturers. So that's an example of an adjacent industry. It's a person that is already working on high voltage cabling in buildings, etc. Could be used by the ports in the transmission sense. So it's industries like that that are using and utilizing components that will be utilized by offshore wind. It's people that are making, casings for cabling. The tower within a wind farm has a lot of cable that runs up and down. So it's people that make harnesses in cable. It's really a wide range of industries that are needed. And so those are 3 examples I would give you there.
Well, we definitely appreciate that insight on adjacent industries and the overall presentation today on really growing and understanding the supply chain and where there are potential opportunities to fit in as this industry continues to grow. So I want to say thank you to both of you for joining us and having this very insightful discussion. To all of the listeners, thank you for joining in as well. We usually announce the next Learning from the Expert webinar series date, but I'm excited to say that, and if it hasn't come across your email inbox already, I apologize, but we have a NYSERDA Offshore Wind and Supplier and Workforce Forum on November 3rd and November 5th. Those will, each day, there'll be 3 hours of programming that really tap into some of the different opportunities that are happening now and evolving now, both with our projects, our ports, and some of the component manufacturing work scopes that are coming out and are in active tender. So we're hopeful that you can join. On Friday, we will send out that registration link so that all attendees, if they're available, can join in. And as Jeff alluded to, one of the trends is business to business networking. That will be an aspect associated with this forum, and participating companies will be able to send requests to other participating companies between November 3rd and November 10th to engage in conversation on synergies, available competencies, timelines, due dates, all of the questions that you're potentially looking to get answered. So please join us if you can. Once again, thank you to Jamie and Jeff, and we will sign off from there.
Thank you for having us. Thank you.
Thank you so much, Peter, and thanks everyone for joining.
Thank you.
Goodbye.